All right, we're going to do more with quantum numbers and electron configuration. All right, so remember, what day was that? Tuesday? When I drew out on the board my S block, D block, P block. Helium, even though it's over here, is considered in the S block, it's just over there. Then your inner transition metals or your lanthanides and actinides are the F block. Okay, so we'll start with hydrogen first. All right, so when N equals 1, what are my possible L values?
2, L values.
0, 1,
Yeah, you do go from 0 to N minus 1, but since N is 1, it's only 0.
Or 0, okay.
So L, possible L values are 0, 1 to N minus 1. So if N is just 1, L is 0. If L is 0, what kind of orbital is that in terms of letters? S. Yes. All right, so the first energy level, I would only have one S orbital. 1 tells me my N value. 0 told me that it's an S orbital. So first energy level, there is one S orbital. It's the lowest possible energy state. All right, when N is 2, my L values would be what?
1.
0,
0.
and 1, yes. So that corresponds to an S orbital and a P orbital. So my second energy level, I'm going to have an S orbital and a P orbital. Within my P orbital, remember I have 3 different orientations, which equals 3 different types of orbitals. So that's why I've drawn 3 here. Okay. Let's just keep going. Let's do N equals 3. When I get to the third energy level, what are my possible L values?
0, 1,
and 2.
2.
So I have, that means I have an S, a P, and what does 2 represent?
D.
D. Yes, so in the third energy level, I have 3S, 3P. How many D orbitals did we say there were? Yes. Okay, so for hydrogen, that's who we're going to talk about first. This is what it would look like if I'm looking at all the possible orbitals for hydrogen. This is what it would look like. But you always start the lowest energy state and you build up. How many electrons does hydrogen have?
1.
1. It only has 1. So we're going to put that 1 electron at the lowest possible energy level. So this would be called orbital diagram. write the electron configuration. So this is what it would look like. And I'll explain all that. Instead of drawing out the diagram, I can simply say hydrogen, that's my element, has one electron in the 1s orbital. Okay, so that 1 is referring to how many electrons I have in that orbital. This tells me my orbital type. This 1 tells me what my energy level are in. Okay, before we do another one, let me go back over here. When you have orbitals with the same energy value, like I've shown here, everything in the second energy level here is the same energy. So the s orbital and the p orbital, same energy level. Same is true for the third energy level here. This marker really sucks. So orbitals with same energy are said to be degenerate. I'm dyslexic moment there. So if I ask you on a test, sometimes I ask this question on
And
every,
what exactly what is degenerate?
it just means they have the same energy.
Okay, okay,
They're
okay,
equal,
okay, okay.
I ask this question on like all the tests you take from now until the final. I'll say orbitals with the same energy are said to be blank. Sometimes a student will miss that question on every single test. So, degenerate means I have orbitals that are the same energy. Why is that important? Because if I had more than this one electron in the s orbital, when I move to the second energy level, these are all equal. So I technically could put those electrons anywhere I wanted to. Because you're always building up based on the energy. You start with the lowest, you work your way up. Okay? However, once we leave hydrogen, things go haywire.
Right. Let's just stick with hydrogen.
Yeah, we're still going to talk about this one
We'll eliminate
element.
all the other elements. Hydrogen is my favorite.
Hydrogen.
It's my favorite.
Yeah. I took chemistry, but we only learned hydrogen. Like, I think it was yesterday I went to Prager, and I see this all the time, but it was some box. It said water without the hydrogen.
Isn't that weird?
That
I'm like,
can't
it's
exist.
not water.
Yeah, it's just oxygen.
That's crazy.
Yeah.
Oh,
leave hydrogen, we now are adding more than one electron. Helium has 2, lithium 3, etc. Well, when I have more than one electron, it causes the energies of these sublevels to split. What I mean by that is, say we're in the second energy level, here would be my 2s orbital. The 2p orbital would be higher in energy. Okay? The reason that is due to the charge interaction. You have two negatively charged particles. They want to separate.
Because they're trying to get to be a noble gas.
Yes.
They're trying to get over to the noble gas.
So here are the reasons it causes them to split. The charge interaction, something called shielding, and then something called penetration.
I like how on the slides where you put where we can get it and
Fill in.
fill it in.
So, I don't think I have to tell you this, but the lower value of L, so say this L is 0, this L is 1. The lower the L value, the lower in energy. Okay, so this s orbital will always be lower than a p orbital because of its L value. I don't really think we need to talk about that. I'm not going to spend a lot of time discussing this, but if you're interested. The charge interaction is a result of Coulomb's law. It describes the attraction and repulsion between charged particles.
Now, how did you put it? Describe the way.
The attraction and repulsion between charged particles. Shielding is, say here's the positive charge, and then there's electrons in here. Draw my arrow. Shielding is essentially exactly what it sounds like. If I have an atom that has, say, electrons in the 1s orbital, so we'll call this squiggly part my 1s orbital. If I go in and put an electron in the 2s orbital, that 2s orbital, is slightly larger. Still an s orbital, so it's still spherical. Well, these electrons can't feel the positive charge of the nucleus as strongly as these in the 1s orbital, because the 1s orbital is shielding my electrons in the 2s orbital from the nucleus. okay? Then penetration. It is essentially this, it's kind of like shielding. Basically, the electrons in the 1s orbital, since they feel the positive charge of the nucleus, since they feel the positive charge of the nucleus, they're kind of going to pull in closer to the nucleus. Then the 2s orbital will do the same, but to a lesser extent. Then the 2p won't really be able to do much because it kind of looks like this. So penetration is just the electrons pulling closer to the nucleus. Yes.
So if the two P's far away from the one that's how long
Because, so it's like, I'm going to occupy the 1s first. The whole goal in chemistry is to be at the lowest energy state as possible. So if it's closer to the nucleus, it's going to be lower in energy. As you move out, that requires more energy in order to put those electrons there and to keep them there, because they're not attracted to my nucleus very much. Okay, so I generally don't ask questions about this. It's there, so hopefully it makes sense as to why we're about to split. Okay. Okay, so go back over here to my orbital diagram. All right. So for a multi-electron atom, so this is going to look a little different than our hydrogen looked. So now, in my second energy level, the S and P orbitals are no longer degenerate. S is lower in energy than the P orbitals. Let me go get y'all.
I can't sit here.
I'm so tired.
Yeah. Oh, I slept so much. We just watched Office. And then I was kind of like, see the stories and that. We like so hard. And I was that, well, as soon as they were letting me that Chick-fil-A. The two other guys, they started with Jesse.
I don't know them, I just know one.
They know you.
Yeah.
There's a tall one though.
Yeah, I know Jacob.
Yeah, Jacob and Jesse.
Yeah.
Yeah, they were really nice.
Look, I'm making more money today.
You didn't wear socks. What is this do?
Catch up. Invest for his little dog.
I need to do this. Will you help me?
Yeah.
Set it up?
Yeah, you have, it's down like Cash App. It's my favorite.
I've got cash out.
I can do it like that.
Yeah, and you can get a cash card and it's free. It's a debit card. So it's, and then you can like get like Chick-fil-A boosts every time you go to Chick-fil-A. It's like 10% off.
Well, we did that now already. We get free Chick-fil-A.
How do you get free Chick-fil-A?
From Al, and he got me Chick-fil-A.
Bloodwood, so it's technically out.
Well, he didn't bring it to us, so, but he got me a Chick-fil-A, it's the night cat, have you seen it?
Yeah, that's cool. That's not
Yeah, he said we need to watch it. I was wanting it to wear in that dog tournament this weekend.
You golf, Jen?
Huh?
Said you golf?
My dad was a golf pro, and I was the only child.
I heard you have a boat.
Huh?
I heard you had a boat.
Yeah, good. Well, my great parents have boats. They're not mine, but
Yeah.
I want you to take me to work like that on me.
me too.
I haven't moved in so long.
I have to,
No, I don't do like the cool stuff that you do and jump fences and stuff. I don't have that horse to make me jump in.
I'll have to figure it out, because I don't have my own horse right now. But
We have
I
horses.
bet my trainer,
Yeah.
I bet my trainer will figure something out.
And then I have friends that have them that don't ever ride them in reunion, but stay on reunion. And they don't ever ride them, and all we do is call them, they have them all set up before we get there, and we can go right there. It's just not, I mean, there's a little trail,
I like reading.
Yeah,
It's really nice.
but, those poor horses, they just got to sit and nobody, and they love for people to come in. One of them's name's Paprika.
That's so cute. Rachel's horse, our live and training horse is out at reunion, but she doesn't really ever ride